Who's my favorite student? Good old Anne Serkey. So the 3 kids that were away, just leave your kids blank, quizzes blank. You can watch. The rest of you, there is a good chance that many of you keep making the same mistake over and over and over. I used to just say to kids, don't do that. And I learned, you know what? Let them make the mistake on the quiz, get angry at themselves, and then they'll remember it. So if you did, you can always redo the quiz. Says, give the name or the formula for the following compounds, 2 marks each. I'm going to walk you through how my brain does this. Now, eventually, Ty, you get good enough that you start to take shortcuts, but they gave me a formula. The first thing I would say is it ionic or covalent? It starts with a metal. In my mind, I would say it's ionic. Is it multivalent? So now I look at Na and I find it on the periodic table. You want to hear a joke about sodium? Nah. I find it on the periodic table. Sodium only has a plus. It is not multivalent, so no Roman numerals. I would say, this one I'll type, sodium chloride. 2 marks each. 1 mark for the sodium, 1 mark for the chloride. By the way, what is NaCl used for? This is table salt. Although table salt typically also has some iodine added for your vitamins, so it's iodized table salt. Iodine helps you keep from getting goiters and all sorts of disgusting things. You only need a little bit, but you don't get enough in your diet, so we add it to salt. Calcium bromide, ionic or covalent? Ionic. Going backwards, now I have to reverse crisscross. So I'm going to write down the calcium. I'm going to write down the bromide. How many calciums are there in this formula? Sorry? Sorry, I got to write down the charge. Let's see. The charge is 2 plus. How many bromides are there in this formula? I don't know. The charge is 1 minus. I crisscross. The formula is going to be Ca1. Do I write the 1? Br2. 1 mark for a Ca with no subscript. 1 mark for a Br2. FeCl2. Ionic or covalent? Ionic. I go find iron and, oh, multivalent. So now I'm going to be bringing out the Roman numerals. It's going to be something like, it's going to, come on, get the cursor there. It's going to be iron something chloride. I need to figure out which charge. And how do I do that? I'm going to reverse crisscross. I'll show you what I mean. I write down the actual formula, which is FeCl2, and then I uncrisscross, Jaden. I say this 2 originally might have been a valence charge, and this invisible 1 originally might have been a valence charge. The problem is, Joseph, that might be wrong. My error check, the way that I check this, is I go find chloride, and I see what's the charge on this. What's the charge on Cl, Joseph? A 1? And is that what I've written up there as my guess? Then you know what? I don't have to do any adjusting. The charge on the iron must have been a 2. Is that possible? Can iron have a charge of 2? Yeah, so I'm not breaking any rules of science or anything like that. By the way, the ones on your periodic table are the most common valence charges. There are other possibilities. That's why I think there's a couple of questions in your textbook or on the worksheet that I gave you where you might have said, hey, wait a minute, it's talking about tin 7, and that's not on my periodic table. It means that's a very rare valence charge, but we assume it's legal. Anyways, iron, bracket, II. So I'm going to be fussy on the quiz. 1 mark for the chloride with the ide rule. 1 mark if you have iron 2. If you missed the 2 on the quiz, I'm going to give you nothing. I'm only going to give you 1 mark for the chloride. So the best you can get is 1 out of 2 because I want it to sting a little bit. And if you're unhappy, feel free to redo the quiz later on and re-email me your score. Copper 1 sulfide. How can I tell that's ionic and multivalent because of the Roman numeral? But this one is actually going to be a little bit easier. That one is telling me which charge to use. So I'm going to use the criss-cross rule. Copper is Cu, sulfide is S. Copper, I have several options. No, they want me to put a 1 there. That's what the Roman numeral 1 means. Sulfide is a 2 minus, I believe. I'm going from memory, but I think that's right. So now when I crisscross, you should get, stay in the same color, Mr. Dueck, Cu 2 of them, S 1 of them, but I'm not going to bother writing the 1. Same idea, Jessica. 1 mark for the Cu2 and 1 mark for the sulfur. Okay. Oh, got someone coming in here. Pause. CaOH2. Okay, this is also ionic because it's starting with a metal, but I've got one of these weird, funky polyatomic ions, so I have to look that up. The name is going to be calcium, and OH is called what? Oh, it's called hydroxide. I guess when you have an O and an H combined, that's a hydrogen, that's where that, and oxide. I can see where they got the name from. Again, 1 mark for the calcium, 1 mark. Is calcium multivalent? Do I need Roman numerals? Oh, whew. I should have checked that, though, before I started writing. Potassium permanganate. What the heck is Oh, you know what? I think that thing is a multivalent ion, so I have to look it up. Potassium is K. What is permanganate? MnO4? Really? What's its charge? Oh, lowercase n. I see. It's not okay. MnO4. And it's got a negative, and potassium has a plus. Oh, you know what? This is a marriage made in heaven because the crisscross matches, right? It's going to be K MnO4. You can, if you want to, Rachel, put brackets around that. I wouldn't take marks off. But since I only have one of them, I would follow it if you didn't bother. So I'm going to put them off. CO2, Cr2O7, well, blah. Okay, well, this is cobalt, which I think is ionic. I have a feeling cobalt is multivalent. It is? Okay, so it's going to be cobalt something, and then what is Cr2O7? That's a polyatomic dichromate. The question is, what goes in for the Roman numeral? I'm going to uncriss-cross and figure out. So I'm going to write the CO. There's 2 of them. I'm going to write the Cr2O7. There's 3 of them. I am going to uncriss-cross. Now, this will be okay if Cr2O7, if dichromate, actually has a charge of 2 negative. Does it? I don't know. Let's go look. It does. So that means it works if cobalt has a charge of 3. What if this had a charge of 4 negative? Well, then I would have to also double this to make it a 6 to make it work. And I think there's, I hope I did one. Hopefully the next one does that. Anyways, it's going to be cobalt, Roman numeral III, dichromate. Same as before, 1 mark, 1 mark. Manganese 3 phosphate, this is also ionic. Manganese is Mg or Mn? Mn. I always get manganese and magnesium mixed up. Manganese is Mn. Phosphate is polyatomic because it ends in 8. PO4. Now, this is, phosphate is negative, 3 negative. PO4, 3 negative. And manganese is multivalent. Oh, no, Ty. They want me to use that charge there, so I put a 3 plus there. Oh, this will work out great, Courtney. When I crisscross, there's going to be a 3 there and a 3 there. Now, if I have a 3 and a 3, do I write 3 and 3, or what do I do with those? I reduce them to lowest terms, which isn't technically lowest, but yeah, that's what we say in science, even though lowest terms really means something different. But you know what I mean. So it's going to be Mn and PO4, one of each. Brackets are optional. 1 mark for the PO4, 1 mark for the NM, from the Mn. Brackets are optional, yep. Covalent, how do I know? Non-metal, non-metal. Covalent, little easier. It's going to be, I'm going to make a mistake. See if you guys spot the mistake. Where's my mistake? Yeah, we don't ever start with mono. It's just like when you write an X, we know there's an invisible 1 in front of an X in math. We don't put it there. So this will be sulfur hexafluoride. 1 mark, 1 mark. I think this is the chemical that when you inhale it makes your voice really deep. It's heavier than air. It's also used as a fire extinguisher because to extinguish fires, all you need to do is take away the oxygen and it will displace the oxygen. Yeah. I think it's sulfur hexafluoride. Carbon dioxide, I'll be honest, I have this one memorized. Well, does anybody know what's the formula for carbon dioxide? So some of you might have that memorized, so if you went straight to CO2. Otherwise, you can see 1 carbon, di, 2 oxygens in the formula. 1 mark for the carbon, 1 mark for the oxygen. Can you give yourself a clear score out of 20, please? Make sure your name is on them, and then pass them towards the center. So, section 4.3, balancing chemical equations. What we're going to look at for the next couple of days, Alex, guys, with me? This is important. Is, I don't know if you ever wondered, how do chemistry nerds look at 2 chemicals and figure out how they're going to combine and in what proportions? This is the beginning of moving from the Middle Ages when they were randomly mixing stuff together to modern day science where we can actually predict how chemical A will combine with chemical B, will combine with chemical C, and what kind of a product they'll form. Now, we're not going to get that high tech. This is the foundational stuff. But here we go. It says this. This might be the toughest, maybe the coolest if you're a nerd, topic we do all year. If you find it difficult, I want you to be aware all that means is that you're normal. Okay? And we're going to start off, Ty, with a basic premise. We're going to say, if we mix 2 chemicals together, something may be formed. What do we call 2 chemicals? Also begins with the letter C. A compound may be formed. Okay? And this is called a reaction, a chemical reaction. In the next chapter, we're going to start classifying types of reactions. We'll even start asking how can you speed up or slow down a reaction. We'll look at, for example, why you guys give off body heat, why your bodies aren't cold, because there are thousands of chemical reactions going on inside you. We'll talk about ways that those get sped up or slowed down. Some important things, some important terms to know. Substances that react are called reactants. How can I remember that substances that react are called reactants? Hey, the word is in there. Substances that are produced are called products. Thankfully, they didn't go all Latin with those names. They used names that make sense. So we have reactants. That's what you mix together. What you end up with is called a product. Here is the first thing that we're going to try and pound into your brain. If you're doing a chemical reaction, you can't create or destroy atoms. In terms of an equation, what that's going to mean, Julia, is everything on the left has to show up somewhere on the right. It can't magically vanish. And not just everything on the left has to show up on the right, but the same number of everything. If you got 3 oxygens on the left of your chemical reaction in your reactants, you know how many oxygens you're going to have on the right? 3. If you've got 8 hydrogens, you're going to end up with 8 hydrogens. Atoms can't be created or destroyed. Therefore, the same number, you know what? I have an abbreviation for number, of atoms must be present after the reaction is over. In fact, this is so important. It has a name. This is the law of, you might figure out the name by looking down a half line. This is called the law of what? Conservation. Conservation is a fancy science term. We talk about the law of conservation of energy. We talk about the law of conservation momentum in physics. Here, conservation means whatever you started with, you end up with. You neither end up with more or less. So this is the law of conservation. And we've only known this for a few hundred years. For the longest time, Sage, people would do a chemical reaction, and the reactants were lighter than when you started, and they just assumed the atoms had vanished. No, what had happened was some of your atoms had turned into a gas, but they didn't have the technology to measure that at the time. Okay? The amount of atoms, the amount of mass before a reaction, if you have a fancy vacuum flask, and you have a really accurate scale and you do a chemical reaction, the mass before and the mass after will be identical. The law of conservation of mass, in fact, is what's going to allow us to predict chemical reactions ahead of time, because we know, Dylan, that everything on the left has to show up on the right. So, more terminology. This is a chemical equation. The plus sign is the shorthand for mixing together, combining together, shaking up in a test tube or whatever. We have the reactants on the left, the products on the right, and when you have a number in front, we call that a coefficient. How many hydrogens are there here grand total? Don't say 2, because there isn't. There's 4. You see it? How many hydrogens are there over here grand total? See also 4? How many oxygens are here grand total? 2. How many oxygens are here grand total? 2, because of that. This is a balanced equation. You have 4 oxygens on either side. 4 hydrogens on either side. You have 2 oxygens on either side. What this is saying, by the way, is you can't form a water molecule with 1 hydrogen and 1 oxygen. You need 4 hydrogens and 2 oxygens. Why is it O2, by the way? This is that Mr. Hofbrinkel. These are those diatomic molecules or atoms that we talked about a few days ago, and we'll be re-mentioning that in this unit. How can we represent equations? Well, first we have word equations. That's where you use the names of the reactants and the products. In the equation above, I would say hydrogen plus oxygen gives hydrogen dioxide, or as we like to call it, water. Then there's something called the skeleton equation. This is where you translate the names into the formulas, but it's not balanced yet. You don't have the same number of H's on either side. You don't have the same number of C's on either side. You don't have the same number of nitrogens on either side. You've got the setup, and then you have to balance it. Key word, Oh, hang on. Sorry. No. Take that back. My bad. Looked at the wrong line. The coefficients, I apologize, Jaden. That tells us how many of each molecule is involved. And here is the key idea. It is always going to be in balance. That's the fancy word that we use. We talk about balanced equations, and it's going to be in lowest terms. So you may find when you're done balancing a very complicated equation, you may look at the coefficients and you may notice, oh, 2 goes into all of them, you can reduce it. Or 3 goes into all of them, and those will be for the most complicated ones. So we have chemical symbols, I think is what I wanted to write. Are used to represent chemical names. I think that's what I wanted to write. I don't know what I wanted to write there. It seemed important at the time. So this tells us what was started, what was added, and the number of each. The fancy word for started, reacted. What you add, so these are the reactants, and how many of each. It's all good. Try holding your breath, kiddo. Deep breath. We can use words. Words are very tough to follow. We're almost always going to use formulas and symbols. So here's an equation. Okay. 2NO plus O2. What do you think that little g stands for? Close. It doesn't stand for grams. It stands for its physical state. I'll give you a hint. Skip down a little bit. The G stands for gas. What do you think a little L would stand for? What do you think an S would stand for? All right, now impress me. What do you think AQ stands for? Alex, what? You're right. Sort of. Mixed in water. And the fancy word is aqueous. Aqueous. I think that's how I spell it. So this will be something that's normally solid, but to mix it better with whatever you're mixing it with, you diluted it, stirred it up into water. Okay? So the X indicates the state. Now let's go back up to this equation. Okay? NO is not no. NO in chemistry, this is nitrogen monoxide. One nitrogen, one oxygen, covalent. This is nitrogen monoxide. How many of them did I start with? How many nitrogen monoxides did I start with? So 2 molecules of nitrogen monoxide reacted with how many molecules of oxygen? Well, Oxygen is never by itself. Oxygen is always O2. So one, not atom of oxygen, one molecule of O2, of dioxide, if you want to say it that way, to form, okay, so we started out with two molecules and one molecule. How many molecules do we get on the right-hand side, grand total? How many molecules do we get on the right-hand side, grand total? Only two. Two molecules of, what would I call NO2? Nitrogen dioxide. So I wrote down here, and we're going to take 5 minutes. Reading check page 205, reading check page 207. What you're going to do is you're going to turn to your lab partner and take turns asking each other the questions in the reading check for both sections, and just rough jot your answers in the space down here. If you don't have a lab partner, I'll part you up with someone, or you can go in groups of 3 if you want. Julia and you guys can go together. Jasmine, blanking out. Okay. Answers are, the first question, I didn't do a formal one. It says, what's the definition of a chemical reaction? Phones away. So I wrote down, jot your answers below. Hopefully you did, or we walked through them. Let's continue on. Next page. You're going to want your periodic table handy. Balancing equations. So we have 3 main ways that we can write an equation, a chemical reaction. The first is the word equation. Potassium reacts with oxygen to form potassium oxide. I hate the word equation. Too much writing. Too confusing. Then we have what we call a skeleton equation. It's called a skeleton because it hasn't been fleshed out yet. You haven't actually done the math. The skeleton equation says potassium combines with K plus O2 gives K2O. And here's how you can tell this is a skeleton. On the left-hand side, how many Ks do I have? 1. On the right-hand side, how many do I have? 2. This is not balanced. What we're going to spend the most time doing, and for the rest of this class, and actually for a few days, Allison, is we're learning how to balance equations. So now pick up your pencils. The balanced equation. Start with the biggest molecule. Here are the hints. In other words, if you ask me to balance this equation, I'm going to start on the right-hand side, not on the left, because K2O to me is bigger and uglier than a K and an O2. Start with the ugliest thing. And then work your way out to smaller molecules like K and O. So first trick, if you don't know what to do, Courtney, start with what's ugly. So, ready? We're going to balance this equation up here by adding coefficients to it. We're going to go like this first. How many K's do I have on the right-hand side? So put a 2 in front there. You all looked up. Look down. Look up. Put a 2 right there. How many K's do I have on the right-hand side? 2. How many do I have on the left-hand side? I've balanced the potassiums. Now let's see, are the oxygens balanced? How many oxygens do I have on the left-hand side? 2. How many do I have on the right-hand side? 1. Okay, now what I'm going to have to do is I'm going to have to put a 2 there. Now that gives me 2 oxygens on the right-hand side. Problem. How many potassiums do I now have on the right-hand side? How many do I right now have on the left-hand side? 2. How many do I need? Now, by the way, you're going to do these in pencil. Lots of erasing. Maybe this is balanced now. Let's see. Taylor, how many Ks do I have on the left grand total? How many on the right grand total? 2 or 4? 4. Because it's 2 times 2, 4. How many O's do I have on the left grand total? 2. How many O's do I have on the right grand total? 2. This is a balanced equation. Ta-da. Okay? I was going to walk you through the steps here in English, but we did it. So you don't fill in the blanks. Let's go to counting atoms and ions. Quick reminder. So if you see F2, how many fluorides is that? 2. How many H's, how many O's in this next one? 2 H's, 1 O. How many phosphoruses in the next one? How many phosphoruses? 2. How many O's? 8 O's. I'll put a dash so it doesn't look like 80 and 10. You okay with where I'm getting these numbers from? Right? We're multiplying. It's sort of like in math FOIL, sort of, kind of, a little bit. This last one is pretty tough because there's several different ways to think about it. You could think about it as simply 3 molecules of Ca3PO42, because that's what that 3 in front means. Or you could break it down further. You could say it's 9 atoms of Ca. Where'd the 9 come from? 3 times 3. And you could treat that PO4 as 1 polyatomic ion, and you could say there's 6 of those, because there's a 2 outside the brackets and a 3 in front. Or you could break it down even further, 9 atoms of Ca, and then you could say 6 atoms of potassium, boom, boom, sorry, potassium, of phosphorus, not potassium, and, oh, how many atoms of oxygen grand total? Well, I got 8 right here, times 3 in front. Which is the correct way? You're going to flip-flop because sometimes the middle way will be easier, sometimes the bottom way will be easier. Let's practice this. This is the steps to balance. I'm going to go really slow, Courtney, and then next class you'll get faster. Here's how you balance equations. The first thing you're going to do is you're going to determine the number of atoms of each element. Step 1. So here is an equation. Right now, how many Mgs do I have? How many magnesiums on the left? 1. How many oxygens? Careful. 2. On the right-hand side, how many magnesiums do I have? 1. How many oxygens? Is that balanced? No. Step 2. Step 2, Alex says, pick an element that's not equal. Well, what's the only one that's not equal? Oxygen. And what you're going to do is you're going to add coefficients in front and then follow the domino effect all the way through. So I got 2 oxygens on the left. I got 1 on the right. So the first thing that I might try is putting a 2 there. How many oxygens do I have on the left? 2. How many do I have on the right? Guys, I need you here. Guys, I need you focused here. How many do I have on the right?
2.
I'll cross out the 1 and I'll say now it's a 2. Oh, but what else changed when I put that 2 there? Magnesiums. How many magnesiums do I have on the right? Cross out the 1, make it a 2. Are we balanced? No. What's the problem now? How can I fix that? I can add stuff to the coefficients. So let's go to the left-hand side. How many magnesiums do I have? How many would I like? So I'm going to put a 2 right there, cross this out, put a 2. And I think I'm going to pause. I'm going to zoom out, double check. Are my numbers below all balanced? Yeah? This is the chemical reaction balanced equation. It turns out don't rewrite this, I will for you though, 2 magnesiums plus 1 O2 will combine to form 2 magnesium oxide molecules. You need to start out with 2 magnesiums, you need to start out with 1 molecule of oxygen, and when you combine that together, you're going to get 2 molecules of magnesium oxide. We're going to practice this and tell the tone. Try these. I'm going to zoom in like crazy. Okay? First thing I do, because this is the skeleton equation, the coefficients aren't in place. Ty, got a question? Or Duncan got a question? Okay. Sorry? I can't hear you. Missed the part at the end? There you go. Okay. You guys ready? Sorry, I need you focused here, and you're chatting quite a bit. So, ready? Next one. We're going to try it together. Sage, I want to pick on you in love. You ready? Right now, this is what we call a skeleton equation because there's no coefficients. How many calciums do I have on the left-hand side right now? It's not meant to be a trick question, meant to be easy. 1. How many oxygens on the left-hand side right now? 2. How many calciums on the right-hand side? 4. Is there a number right there? So how many calciums? What number is sitting right there? It's invisible. 1 calcium. How many oxygens on this side? 1. Is that balanced? Do those 2 numbers match those 2 numbers? Is that balanced? No. So we're going to have to do some adding in the coefficients. So let's see. How many which is the unbalanced part? Calcium or oxygen? So let's start working with oxygen. How many oxygens are there on the left? What did you say? 2. How many do I need on the right then? 2. So I'm going to go like this. I'm going to say, to make that a 2, I need to multiply by 2. But what else does that change? On the right, now calcium has 2. Right? Are we balanced? Zoom out. No. What else how else can I change this? Put a 2 there, and that gives me a 2. Are we balanced? So the actual equation, balanced, is 2 CAs plus 1, I never write the 1, O2, results in 2 Ca2s. Or in words, 2 calcium atoms plus 1 oxygen molecule of 1 O2 molecule results in 2 molecules of calcium oxide. Didn't say this was easy. We're going to do one more before the tone. Okay? Allison, my joy, I'm going to pick on you. I know these are tough. You ready? On the left, how many N's are there on the left-hand side right now before we start out? Yes. How many H's on the left-hand side? 2. On the right, how many N's are there? How many H's? 3. Can I give you some advice? And we're going to write this down later. When in doubt, if there's several things that aren't balanced, and both of them aren't, try and leave oxygen and hydrogen for last because they're the most complicated, and sometimes it'll just take care of itself if you get the rest of them done. So we're going to start with the N's, with nitrogen. How many N's on the left? How many on the right? I can fix that by temporarily putting a 2 there. Now, careful, as soon as you do that, change. That becomes a 2, that becomes a... Okay. Are my nitrogens balanced? Yes. What about my hydrogens? How many H's do I have on the right? 6. How many on the left? Any way I can change that to 6 somehow? Add a 4, add a 3. Add a 3, and that gives me 6, because we multiply, right? It turns out the balanced equation, if you want to combine nitrogen and hydrogen to form NH3, you need one N2 molecule plus 3 H2 molecules to get 2 NH3 molecules. Or if I said it in English, 1 dinitrogen plus 3 dihydrogens gives 2 nitrogen trihydride, because it's covalent. We're going to pick up with this next class.